Hi there, Mr. Benjamin here, and today we'll be doing 2014 question number 2. So let's look at this question together. Alright, chromium is a metal, can be used as a protective metal for both steel and pure iron. Alright, so over here, stainless steel is an alloy of iron that contains almost 20% of chromium mixed together with iron. So below shows the arrangement of atoms in stainless steel. So we want to use the ideas of the arrangement of atoms in stainless steel to explain why stainless steel is harder than pure iron. So this is a standard 4-part explanation. So we will first say that the added atom in steel is different size than iron. So that's the first line. They are a different size. Right? After that, because of this different size, the orderly arrangement of atoms is disrupted. This is the second one. And then the third and fourth point is layers of atoms unable to slide over one another when force is applied. So this is how we explain why alloys are stronger and harder than pure metals. So firstly, different size, disrupt orderly arrangement, and then the layers cannot slide over one another when a force is applied. Okay, so that's how you do this. So next, chromium in stainless steel, right, reacts with oxygen in the air to form chromium oxide. The chromium oxide forms a layer on the surface of the stainless steel. So this layer sounds like it's a physical barrier, right? Physical barrier. So it's sort of a physical protection from rusting. Right, so the formula of chromium oxide is Cr2O3. What's the formula of chromium ion? So this one is like 2 minus times 3. So the chromium should be a Cr3 plus. Now, suggest how the layer of chromium oxide stops the iron from rusting. So because this is a physical barrier, remember there are some keywords that need to be there. Okay, so we will say that chromium oxide acts as a physical barrier. That's the first word that needs to be there. And what does this physical barrier do? As a physical barrier, that prevents iron from coming into contact with oxygen and water. So what needs to be there? It needs to be a physical barrier that prevents iron from coming in contact with oxygen and water. Alright, so please remember these keywords are actually very important. Okay, next. So now it's not chromium oxide, but you see it's coated with chromium, right? Just now was coated with chromium oxide. Now it's coated with chromium. Now chromium is more reactive than iron. So we can imagine that this is some sort of chemical method, right? This is some sort of chemical method to prevent rusting. So when the chromium coating is scratched, will you expect the iron underneath to rust? So because it's a chemical method now, just now was chromium oxide, now it's chromium. When it's scratched, iron will not rust. Why? Because chromium, so since chromium is more reactive than iron, okay, then we must remember it will NS chromium oxidizes preferentially over iron. So therefore, iron will not rust. Okay, so that's the chemical protection. So oxidizes preferentially, that's one, and more reactive. Okay, please do not use the word sacrificial protection without explaining this. So what's the method that I can use to coat the chromium? I can use the method called electroplating, or we can use the word electrolysis. Okay, so I hope I helped you with 2014 question 2. All the best. Bye.